Welcome to our latest video on the topic of halogenoalkanes, nomenclature and classification. This video is suitable for AS and A-level chemists. By the end of this video lesson, you should be able to use the IUPAC rules to name and draw the structural formulae of halogenoalkanes. And you should be able to classify halogenoalkanes as either primary, secondary or tertiary. Now, halogenoalkanes are a homologous series in which one or more of the hydrogen atoms from an alkane have been replaced by a halogen. And halogenoalkanes have the general formula CnH2n+1 X, where X is a halogen atom such as a fluorine, a chlorine, a bromine or an iodine. And halogenoalkanes can be either aliphatic or aromatic. And some examples of halogenoalkanes are shown here on this slide. Now, aliphatic halogenoalkanes consist of either straight chains, branch chains, or non-aromatic rings. And the first two halogenoalkanes on this slide are aliphatic in nature, bromoethane and chloromethane. Now, the remaining halogenoalkanes on this slide are aromatic in nature, because they contain a benzene ring. And the halogen can be either directly attached to the ring, as in the case of bromobenzene here, or it could be attached to a side chain on the ring. Either way, they would still be classed as aromatic halogenoalkanes. Now, halogenoalkanes are named using the IUPAC rules, just like every other organic compound. And IUPAC stands for the International Union of Pure and Applied Chemistry. Now, halogenoalkanes are named in the same way that alkanes are, by considering the halogen atom as a substituent on the alkane chain. There are a few rules you need to remember when naming halogenoalkanes. The first rule is that you need to find and name the parent chain. Now, as in naming alkanes, you have to select the longest chain as the parent chain. And then the second rule is you have to number the carbons of the parent chain, beginning at the end nearer the first substituent, regardless of whether it is a halogen or not. Now, you have to assign each substituent a number according to its position on this parent chain. And the third rule is if more than one of the same kind of halogen is present, you have to number each and use one of di, tri, tetra. Di means 2, tri means 3, tetra means 4. Now, the final thing to remember when naming a halogenoalkane is to put the substituents in alphabetical order. So bromo comes before chloro because B comes before C in the alphabet, and chloro comes before ethyl because C comes before E in the alphabet. Now, you also have to remember that di, tri and tetra do not count alphabetically. Dichloro counts as a C, not a D, and triethyl counts as an E, not a T, because di, tri and tetra do not count alphabetically when naming a halogenoalkane or any homologous series. So to illustrate these rules, let's look at some examples. So in my first example, I have a longest chain of 6 carbons. So the compound's name is going to end in hexane because there's 6 carbons in the longest chain. And I have 2 substituents, a bromine and a chlorine, on this 6 carbon parent chain. Now, if I number the carbons left to right, as I've done in red here, the bromine and the chlorine are on carbons 2 and 3. Now, if I number them right to left, as I've done in green here, the bromine and the chlorine are now on carbons 4 and 5. Now, I have to have the lowest numbers for these substituents. So therefore, numbering them left to right, as I've done in red here, gives me the lowest possible numbers for the substituents, because 2 and 3 are less than 4 and 5. So therefore, to number them in red here, left to right, is the appropriate way of doing it. So therefore, if I'm going to put these in alphabetical order, bromo comes before chloro because B comes before C in the alphabet. So this compound is 2-bromo, 3-chlorohexane. So when naming a halogenoalkane or any other homologous series, you always put a hyphen between a number and a word and a comma between two numbers. So if we look at this example, it's 2-bromo, 3-chlorohexane, and I put hyphens between the 2 and the bromo and the 3 and the chloro. Now in our second example here, the first thing I have to do is number the longest chain. So this is the parent chain and this has 3 carbons in it. Therefore, this compound is going to end in propane when I name it because propane has 3 carbons in it. And if I number the substituents left to right, as I've done in red here, the bromine and the chlorine are on carbon 3. Now on carbon 2, we have a methyl group, a CH3 group. Now the alternative way to number this would be right to left, as I've done in green here. And if I number it right to left, the bromine and the chlorine are on carbon 1, and the methyl group is on carbon 2. So to decide which way I have to number it, I have to have the lowest possible number for the substituents. So if I number it left to right, they're on carbon 3 and 2. And if I number it right to left, they're on carbon 1 and 2. So therefore, I number it right to left. So the name of this compound would be 1-bromo, 1-chloro, 2-methyl propane. Now when naming organic compounds, you always put a hyphen between a number and a word and a comma between two numbers. So now let's look at another example. So in the compound we've drawn here, there are 6 carbons in the longest chain. So this compound is going to end in hexane when we come to name it. And if I number it left to right, as I've done in red here, the substituents, the chlorines, are on carbons 2, 3 and 4. And if I number it right to left, as I've done so in green here, they're on 3, 4 and 5. Now the rule is I always have to have the lowest possible number for the substituents. So 2, 3 and 4 is lower than 3, 4 and 5. So therefore the name of this compound will be 2,3,4 trichlorohexane. And remember, tri is a prefix that is used when there's 3 of a particular substituent. If there was 2 of a substituent, it would be di, and if it's 4 of a substituent, that would be tetra. Now when naming organic compounds, the prefixes di, tri and tetra do not count alphabetically. So trichloro alphabetically would be a C for chloro. It wouldn't be a T for tri. And once again, you should notice here that we put commas between numbers and hyphens between numbers and words. So let's test your understanding of naming with some practice questions. So pause the video and have a go at naming these 2 compounds, and then we'll show you another 2 compounds we'd like you to have a go at naming, and then we'll go for the answers to questions A, B, C and D. So here are compounds C and D. Once again, pause the video, have a go at naming them, and then we'll go for the answers to questions A, B, C and D. So let's have a go at naming compounds A and B. So the first thing I have to do with compound A is find the longest chain, the parent chain. So there's 5 carbons in the longest chain, so the compound's name is going to end in pentane. So after finding the longest carbon chain, I have to number the carbons so that the substituents have the lowest possible numbers. So if I number it left to right, as I've done so in red here, the substituents, the bromine and the methyl group, are on carbons 2 and 3. And if I number it right to left, as I've done so in green here, the substituents are on carbons 3 and 4. 2 and 3 are lower numbers than 3 and 4. So to number it left to right, as I've done so in red here, is the correct way of numbering it. And therefore the name of this compound would be 2-bromo 3-methyl pentane. Now once again I have to remember that I put a hyphen between a number and a word. Now if we look at the second question, question B, the compound here has 5 carbons in its longest chain again, so it will once again end in pentane when we come to name it. And if I number the carbons left to right, as I've done so in red here, the substituents, the bromine and the iodines, are on carbons 1, 2 and 4. So the 2 iodines are on carbons 1 and 2 and the bromine is on carbon 4. Now if I number it right to left, as I've done so in green here, the substituents are on carbons 2, 4 and 5. The bromine is on carbon 2, the iodines are on 4 and 5. Now 1, 2 and 4 are a lower set of numbers than 2, 4 and 5. So therefore, to number it left to right is the appropriate way of numbering it. So the red numbers are correct here. So therefore this compound would be 4-bromo 1,2-diiodopentane. Now remember, it starts with bromo because it's alphabetical order. Bromo comes before iodo. So it's 4-bromo 1,2-diiodopentane. And there are hyphens between words and numbers and commas between two numbers. So now let's go through how I name compounds C and D. So the first thing I need to do when naming a compound is find the longest carbon chain. So this parent chain here is 6 carbons long. That's the longest carbon chain. So the compound's name will end in hexane. And then what I have to do is I have to number the chain so that the substituents have the lowest possible number. And if I number it left to right, the substituents are on carbons 1, 2, 4 and 5. And if I number it right to left, as I've done so in green here, the substituents are on carbons 2, 3, 5 and 6. Now 1, 2, 4 and 5 is a lower set of numbers than 2, 3, 5 and 6. So therefore, left to right is the appropriate way of numbering it, as I've done so in red here. So if I'm now going to name this compound, I have to put the substituents in alphabetical order. So the first one I'm going to put down is bromo, and the bromine is on carbon 5, so it would be 5-bromo, and then chlorine comes next alphabetical, so it's 5-bromo 1,2-dichloro, because there's 2 chlorines, and then the last substituent alphabetically is the methyl group, so it would be 5-bromo 1,2-dichloro 4-methyl hexane. Now once again, I put hyphens between numbers and words and commas between two numbers. So now let's look at compound D. So once again I have to find the longest carbon chain, the parent chain, and once again this is 6 carbons long. And then I have to number the chain so that the substituents have the lowest possible numbers. So if I number it left to right, as I've done so in red here, the substituents are on carbons 2 and 3. I have a bromo on carbon 2 and I have a methyl and a chlorine on carbon 3. Now if I number it right to left, as I've done so in green, the substituents are now on carbons 4 and 5. Now 2 and 3 is a lower set of numbers than 4 and 5. So therefore, when numbering the carbons in this compound, left to right is the appropriate way of numbering them. So the red numbers are correct here. So if I'm going to name this compound, I have a bromine on carbon 2, and I have a chlorine on carbon 3 and a methyl on carbon 3. I have to put the substituents alphabetical. So bromo comes before chloro, comes before methyl. So the name of this compound is 2-bromo, 3-chloro, 3-methyl hexane. And I put hyphens between numbers and words here. So here's our second set of questions. So once again, read through the questions, pause the video, have a go at them, and then we'll go for the answers. So for question 2, we're asking you to name the following compounds, and we've drawn for you here shortened structural formulae. So if we look at question 2a, there are 4 carbons in the longest chain here, and the bromine is on carbon 2, so the compound is 2-bromobutane. And if we're looking at question 2b, there are once again 4 carbons in the longest chain, and this time the chlorine's on carbons 2 and 3, so the compound is called 2,3-dichlorobutane. Notice we put a comma between 2 numbers and a hyphen between a number and a word. And for question C, there are 4 carbons in the longest chain, and a bromine is on the first carbon, so this is 1-bromobutane, and we put a hyphen between the 1 and the bromo. So for question 3, we want you to draw the full structural formula for the following compounds. And the 2 compounds here are 3-bromohexane and 2,2-dibromopentane. So pause the video and have a go at drawing the structural formula for these compounds. And then we'll have a go at questions C and D, where we have 2 more compounds for you to have a go at drawing their structural formula. So here's questions C and D. So once again, pause the video and have a go at drawing the structural formula of these compounds. So now let's go for the answers to question 3. So for question 3a, you're asked to draw the structural formula for 3-bromohexane. So you have to draw 6 carbons in the longest chain, and you have to put a bromine on carbon 3. And for question 3b, you have to draw 5 carbons in the longest chain, because you're asked to draw 2,2-dibromopentane. So you have to draw 5 carbons in the longest chain, and you have to put 2 bromines on carbon 2. Now for question C, you're asked to draw this full structural formula for 1-bromo 2-methyl hexane. So you have to draw 6 carbons in the longest chain, and you have to put a bromine on carbon 1 and a CH3 group on carbon 2. And for question D, you're asked to draw the full structural formula for 1-bromo 3-chloro 4-methyl hexane. So you put a bromine on carbon 1, you put a chlorine on carbon 3, and you put a methyl group, a CH3 group, on carbon 4. Now with halogenoalkanes that have 1 halogen atom present, it's useful to be able to classify them as either primary, secondary or tertiary halogenoalkanes. And the term primary, secondary and tertiary is dependent on the number of alkyl groups bonded to the carbon atom attached to the functional group, in this case the halogen. Now if it's a primary halogenoalkane, it has 1 alkyl group attached to the carbon next to the halogen. And if it's a secondary halogenoalkane, it has 2 alkyl groups attached to the carbon next to the halogen. And if it's a tertiary halogenoalkane, it has 3 alkyl groups attached to the carbon next to the halogen. So the best way to illustrate this is with an example. So I've drawn here chloroethane, And chloroethane is classed as a primary halogenoalkane because if I look at the carbon next to the halogen, there is one alkyl group, a CH3, attached to this carbon. Now, primary halogenoalkanes have one alkyl group on the carbon next to the halogen, so therefore chloroethane is classed as a primary halogenoalkane. Now, if there were two alkyl groups attached to the carbon next to the halogen, it would be a secondary halogenoalkane. And if there were three alkyl groups attached to the carbon next to the halogen, it would be a tertiary halogenoalkane. So we now like to test your understanding of classification with some practice questions. On this slide, I have 4 halogenoalkanes for you to classify, and on the next slide, we have another 4 halogenoalkanes to classify. So read for the question, pause the video, and have a go at classifying these halogenoalkanes, and then we'll look at the next 4 compounds to classify. So here are the next 4 compounds we'd like you to have a go at classifying. So pause the video, have a go at the questions, and then we'll go for the answers to the 8 compounds and their correct classification. So now let's go through each of the 8 compounds and classify them. So compound A is classed as a primary halogenoalkane because if I look at the carbon next to the iodine, there's one alkyl group attached to this carbon. And B is classed as a tertiary halogenoalkane because if I look at the carbon next to the bromine, there are 3 alkyl groups attached. And C is classed as a secondary halogenoalkane because if I look at the carbon next to the bromine, there's 2 alkyl groups attached. And if I look at D, D is also classed as a secondary halogenoalkane because if I look at the carbon next to the chlorine, there's 2 alkyl groups attached. So now let's look at the next 4 compounds. E is classed as a secondary halogenoalkane because if I look at the carbon next to the bromine, there's 2 alkyl groups attached. F is also classed as a secondary halogenoalkane because if I look at the carbon next to chlorine, there are 2 alkyl groups attached. G is classed as a tertiary halogenoalkane because the carbon next to the fluorine has 3 alkyl groups attached. And H is classed as a primary halogenoalkane because there's 1 alkyl group attached to the carbon next to the bromine. Now, when we come to study the alcohols topic, we also use the classification primary, secondary and tertiary. And this time, a primary alcohol is an alcohol where the carbon next to the OH group has 1 alkyl group. And a secondary would have 2 alkyl groups on the carbon next to the OH group. And a tertiary would have 3 alkyl groups on the carbon next to the OH group. So this concludes our video lesson. So after watching this video lesson, you should be able to use the IUPAC rules to name and draw the structural formulae of halogenoalkanes. And you should be able to classify halogenoalkanes as either primary, secondary or tertiary. So that concludes our video. Please check out our YouTube channel, Dr. O Chemistry, and our Twitter site, which contains lots of chemistry information and links, @RadaChemistry.